In this lesson, we're talking about conditional probability. And very frequently, we are talking about conditional probability in the context of experimental probability. So you'll see a lot of our answers being expressed in percents. When we're talking about conditional probability, we are talking about the probability of an event occurring under the condition that something else has already occurred. So for example, you see in problem 1, we are using the contingency table at the right to find the probability in part A that a student is female given that she's at a graduate school. So I look at how many graduate school students I have. I use my calculator to add that up. And the females in that category are my numerator. And when I evaluate that, it's 59.2%, approximately. So in part A of the second problem 1, it says, what is the probability that a student is at a 4-year university given that the student is male? So I start with the males column, and I add up those values. So 1866 plus 4324 plus 1349 is 7539. And my numerator for that is the 4-year students that are males. So that's 4324. So 4324 divided by 7539, and that's 57.4%. Now it says without calculating, given that a student is enrolled in a 4-year college, is it more likely for the student to be male or female? According to our data, it looks like it would be a female. There's more females than males at a 4-year college. Similar idea. Americans recycle increasing amounts through municipal waste collection. The table at the right shows the collection data for 2007 was the probability that a sample of recycled waste is paper. So you want to make sure that you're reading the question carefully and figuring out what is the given and what is the first thing and what is the second thing. Okay, so I'd hope that you'd realize that, for example, back here, the probability of male, given that it's a 2-year college student, for example, would not be the same as the probability of a student being at a 2-year college given that they're male. Okay, so I want to stress to you the importance of understanding the order in which you're figuring this out. So, what is the probability of the sample of recycled waste? So we are given that we're looking at recycled waste. We're trying to find the probability that that waste will be paper. So what we're trying to find is P of paper given that it is recycled. So we start with the recycled column, and that's our denominator. And that's 79.4 with this being our numerator. And in our calculator, we get 0.569, so on and so forth. And the answer that most closely represents that is choice D in this multiple choice problem. So in the next problem 2, it's asking what is the probability that a sample of recycled waste is plastic. So again, you've got to read that really carefully and realize we are finding the probability of plastic given that it's recycled. So I'm using the same denominator again, 79.4. And my numerator this time is 2.1. And that is 2.6%. Part A. So part B down here, again, reading it carefully, we realize that what they're asking us for is the probability that it'll be glass, given that it's recycled. So we're using that same denominator again, 79.4, with 3.2 in the numerator. And that is approximately 4%. I apologize profusely. This formula for finding conditional probability is not in your notes. So you probably want to copy that down. And in this problem, we're going to use this formula, even though we could do it the same way we've done the last few examples. But I do want you to realize that you'll end up with the same answer either way. So let's practice it using what we've already seen. So here, we want to use the formula, which means I want to start with the probability that they pay online and they are a male. So that's 12 out of 50 is my probability of male and online. And then according to the formula, I want to find the probability, since the question says, given that the consumer is male, my denominator is the probability of the person being male. Now, the problem told us that there's 50 consumers. So if you were wondering where this 50 came from, I hope I've clarified that now. I apologize for not mentioning that sooner. So the probability that someone in this survey will be a male is 20 out of 50. And according to the formula, I'm going to take those two proportions and divide them. Okay, so that's the probability of online, given that it's a male, is 12 over 50 over 20 over 50. And when you flip and change, you end up with 12 over 20, which is 3/5. So the reason why I wanted to do that example using that formula is because here we don't have a contingency table. We just have a bunch of data. And you see that in the problem 4 title, it says using a tree diagram. So this problem is talking about how it starts with 85% of students graduating from high school. And then it talks about of the percent of the students that graduated, 90% are happy with their jobs, whereas those that didn't graduate from high school, 60% are happy with their jobs. So we're going to use a tree diagram to kind of diagram that data. So if they graduated, they're over here, and if they didn't graduate, they're over here, and 85% of the students graduated from high school. So this is 0.85, which means that the students that didn't graduate high school account for 0.15. But then each of those branches further to, are they happy with their job or not happy with their job? Okay, so I'm going to call this happy and this not happy. And of those that graduated high school, 90% are happy with their job, and that means that 10% are not. Similarly down here, happy, not happy. That's 60%, so 0.6 compared to 0.4. So now we've diagrammed out all of the data. Now what are they asking us? They're asking, what is the probability that a person from the junior class 10 years ago graduated from high school and is happy with his or her present job? So when we diagram all our data like this, it makes it very easy to see that we're interested in the people on this branch. So that branch is 90% of the 85% that graduated. So we just multiplied 0.85 times 0.9 . And that's 76.5%. This last example is referring back to that same diagram. It's asking, what is the probability that a student from the junior class 10 years ago in problem 4 did not graduate and is happy with his or her present job? So for this problem, we're interested in this branch. And once again, it's a matter of taking 60% of the 15%. Which is 9%. If there was ever an example that made you want to stay in high school, this is a good one. 9% compared to 76.5%. Think about it.